everybody. Welcome to the second session on the Safety by Design webinar. So what I'm going to talk about now is safety by design and risk governance, and how we try to bridge these things in general terms as part of the Calibrate project. And I will also try to illustrate a little bit what we understand by the framework and how it's connected to the tools that is going to be presented in more detail after my presentation. So this is kind of setting the scene for the presentation of tools that we are going to see later this afternoon. Next slide, please. So if we start from the very basic, we have two elements that we are thinking of as fundamental elements in our safety by design and risk governance framework. So first of all, if we consider the safety by design concept, we see that most innovations follow sort of this Cooper stage-gate idea to launch model, which is the scheme you see in the upper half of this slide, where the innovation goes from an idea or discovery of an idea, and then you make decisions along the road during your innovation. So you have an idea screen whether you actually like the idea. You may move forward to a scoping stage. Again, you make a decision, you build your business case, you decide whether you want to go to development, you go to research and development, you go further and decide to go to actually testing and validation, and finally you may decide to go to a launch of a product. And then finally you have in the post-launch stage, you also need to follow up by post-launch review. That means that you take your ever-growing knowledge about safety and product applicability and the market, etc., into account, and decides whether you want to continue with your production of your innovation. We think that these decisions that you make along this route from idea to a launch of a product can be supported by risk assessment. So if risk assessment is taken seriously into account during the innovation, you might be able to improve your product. You might be able to make a safer product. You may actually start saving money because you make hopefully more clever decisions at earlier stages and don't have to go back from a late innovation stage gate and restart because you discover that the feasibility of your production or the product is not good. On the other side, you have at the lower level, at the lower side of the slide, you have a emerging risk management framework that was developed as part of the NTech risk projects. And conceptually, you have in this model, you have a early stage which is called horizon scanning or early warnings, is a question or is an issue about when do you identify a risk. It can be any risk. It can be financial, or it can be health or environmental, or something related to the production or market. And then you go to a step called pre-risk assessment if you cannot complete a full risk assessment. A pre-risk assessment means that you do a risk assessment based on maybe a limited number of informations. So if you think about a new technology, that would be a typical issue, that you have relatively little knowledge about the details of the risks, but you do know something, and maybe you can learn from history as well. So you take that into account in your pre-risk assessment, and can then make a risk management decision as part of that. This is something that can be applied also during innovation, that you try to look forward, you try to assess the potential risks of the material when you make your development. It can also be assessment of your production methods, that you may have highly useful and not harmful product, but the production method might be harmful. So that is another aspect of the risk assessment that needs to be taken into account. If you have more knowledge, you do a risk assessment on a full scale, and you might even be able to use conventional models. if you click next time, Claire. When we look at the risk assessment that you do, or the pre-risk assessment that you do during innovation, this is mostly related to what the stage gates 1 to 4, so before you go to the launch. And the idea about the safety by design is that you have a exchange of knowledge from the innovation funnel and the risk assessment part of the stage gate assessments. And in this way, you do responsive innovations. You say you change your product, you change your material depending on the risk assessment results. You might decide that it's not needed, but you can also decide that it is needed. And in that way, you can, on the way during development, continuously improve your product or your material or your production method, taking into account the pre-risk assessment methodology that you apply. Next slide, please. So if we try to look at this in a little bit of a different picture, we try to align now the different methodologies to this innovation stage gate funnel. In this slide, I've aligned conceptually the different methodologies and how they can support, or where they can support, the innovation funnel. So for example, at the low end, we have models that do pre-risk assessment. They are applicable for the earlier stage gate, maybe up to around gate 4, until you go to testing and validation. You may also be able to do predictive risk assessment, so you have more information about your material and the product that you can apply in your risk assessment, and you can predict based on physicochemical parameters, for example, or maybe you do have some cell studies that can show you or give you an indication of a hazard of a material, or you may have some exposure measurements that can be used for predicting the potential exposure, or release measurements that can be used to predict the potential exposure. And this can then support your decisions. If you move up to the higher end before you go to the launch, you need to comply with a regulatory environment. So you need to do something that is accepted for regulatory risk assessment. And that's where we currently today have an issue that most of the models, if not all, when it comes to the regulatory environment, are not demonstrated to actually work for nanomaterials and nanoproducts. And that's why we have this challenge and all this process about making risk assessment methodologies specific for nanomaterials. So as part of this, we have a yellow bar called Safety by Design, or Safe by Design, and this Safe by Design is then building on these risk assessment methodologies or tools. So safety by design can be a tool, but it can also be a framework that you link into different methodologies. Another methodology is decision support, where you may use partial information, and a system that more statistically takes the different information into account can also be actual toxicological studies with raw data and a statistical assessment on both exposure and the hazard of a certain material or a certain product. So these are different ways to take such models into account. Next slide, please. So if we now take a look into the site along each stage gate, we in principle need to have a system that fits each stage gate, and luckily there will be some overlaps, so maybe there will only be 2 or 3 of such systems or model systems or frameworks. So here is the complex picture with the we call it risk innovation governance interface, but where you will be able to go down to the specific methodology that you require to make your assessment. It may be that you only need to do exposure assessment. That means that you have to be able to go directly to an exposure model that fits your specific scenario. I have highlighted the safety by design framework, which will be discussed later. And you see here that the safety by design framework is also supported by these integrated human risk assessment and integrated environmental risk assessment models, and potentially also of other predictive models, such as a model that can predict the physicochemical properties of nanomaterials could be useful for safety by design. So you see that both the safety or risk innovation governance and the safety by design framework can be supported by the same tools. not necessarily, but as we will see that, or at least at this point, many of the tools are actually supporting both systems. Next slide, please. So if we now move into an example with the integrated human risk assessment models, you now see these different types of these different levels of risk assessments you can do based on model complexity. So as part of the SUN project, we established a framework where we looked into four tiers of risk assessment, where the lowest tier is a risk categorization methodology. This is a system where you do not actually scale the hazard or the exposure necessarily, but you indicate that there is potentially a hazard that should be taken into account, or an exposure that should be taken into account. So this is a type of model that flags the problems or potential problems. And then we have a tier 1 level of tool, which is control banding, which is more qualitative risk assessment, but it starts to scale. And it's usually based on some sort of hazard grouping and exposure potentials or exposure characteristics. And tier 2 in this model is a basic predictive risk assessment, is where you try to estimate based on quantitative relationships between properties and exposure or the hazard. And finally, you go to the quantitative predictive risk assessment, and here it's mostly connected to the airborne exposures, where this phenomena of particles changing size due to agglomeration, etc., are important for understanding the exposure, as well as advanced ways of doing exposure mitigation through ventilation and understanding how particles penetrate ventilation systems. We think that tier 3 models are not necessarily for at industry level, but are more specialist tool at this point. But it depends, of course, on the specific industry.
Keld, I have to hurry you along a little bit.
Yes, this is the last slide, I think so. That's good. Yeah. So this is so all these models are supported by data libraries, which are important, and was also discussed earlier today, that this is really needed to support the methods and on the long term generate statistical data. So we also have predictive models compared with actual exposure data, for example. So thank you very much. This was a short intro to the area.